Hello everyone. During this video we will discuss Week 2 concepts for CS 200. This is Linda Gaston, your instructor. So this video will contain the Week 2 Python concepts as well as hints to finish the Zidebook Lab 3.11 Painting a Wall. I will post a video solution containing actual programming code for Lab 3.11 during Week 3. One of the things you learn in Week 2 is about the use of variables. So, as you may know by now, a variable is a name that represents values stored in the computer's memory. So your program will create and access and manipulate data that's stored in memory. And we label this data by using variables. So variables represent the values that we store and use to calculate results and to do work in our programs. One common structure that we use is called an assignment statement in Python. It's used to create a variable and to reference that data in the variable in memory. The general format of the assignment statement is variable name equals some expression. As in this example, age equals 29. So the assignment operator is the equal sign. So the value of 29 is put in a variable called age, which is stored in memory. So in an assignment statement, the variable receiving the value is on the left side, and that variable can be passed as an argument even to a function. But we shouldn't include variable names in quotes. And you can only use a variable if a value is assigned to it. So if we want to use some variable in a mathematical calculation and there's no value in it, the result of that calculation will be undefined. There are some rules for naming variables, and this is very important because your Python interpreter is parsing through your code, interpreting and executing the code, and it's expecting certain rules to be followed. So, variable names cannot contain Python keywords like print. Variable names cannot contain spaces. That's confusing to the Python interpreter. The first character of a variable name must be a letter or an underscore. That is what the Python interpreter is expecting. But after the first character, you can use any letters, digits, or underscores. So for example, we couldn't create a variable starting with the number 0. But if we follow the rule to start it with a letter or an underscore, any of the succeeding characters could be zeros, letters, digits, or underscores. And variable names are case sensitive. So that means that a capital letter is interpreted differently by the Python interpreter than a lowercase letter. So a variable name cat, for example, spelled lowercase c-a-t, is interpreted very differently than the capital letter C, capital letter A, capital letter T. Python interpreter would not consider that the same variable name. And also, it's good practice for the variable names to reflect its use. So, if you're storing a value in a variable that will hold the results for some payroll calculation, that variable name should be perhaps payroll underscore value or something related to the calculation. Other rules surrounding names are that, once again, keywords are not allowed. So you'll notice the print keyword and a number of others that you'll learn as you progress in Python cannot be used as variable names. When we do expressions with variables or numerical calculations, we can use the following operators. So these should look familiar to you: plus, minus, multiplication, division. This is for the modulus, or to calculate and give you the value of the remainder of a division expression. And 2 stars are exponentiation. So x to the second power would be x star star 2. So as stated, we can use variables in mathematical calculations. For example, we could have this this expression num apples equals 8, and then we could have another expression total apples equals 2 times the number of apples minus 1. So again, these expressions can be simple expressions like assigning a value of 8 to number of apples, or calculated or more complicated expressions like this one. And then we can print the total apples. So once again, we have the print function, and we're sending this variable total apples to it, and it will display to the screen. Here's how it works. Here's what's happening in the background. Let's say we have this assignment statement that Bob's salary equals $25,000 and Tom's salary equals $30,000. Just simple assignment statements. But let's say we want to make Bob's salary equal to Tom's salary. This statement here would do that, and it's executed by the Python interpreter in this way. So now we have Bob's salary equal to $30,000 instead of its previous $25,000. The next statement says Tom's salary equals Tom's salary times 1.2. Notice how $36,000 is now in memory for the variable Tom's salary. This following expression, total salary equals Bob's salary plus Tom's salary, will result in $66,000 going into the variable Tom's salary in memory. Let's talk a bit more about displaying output with the print function. Once again, this is pre-written code that performs an operation. The print statement is actually a function, and its default value is to display output to the screen. So if we print total apples, the variable total apples will be printed to the screen. The value inside the parentheses are called arguments. This is the data that's given to a function for execution. We also use strings and string literals. So strings are just sequences of characters. If we assign a value to a string, a literal value that we want it to contain, we put that value in single quotes or double quotes. Now it's just good convention to stick with one or the other. We can also use comments in our program. These are just explanatory notes for humans about something that the code is doing. They're ignored by the Python interpreter. So we can have different types of comments, but the reason why they're important is because professionally, code is not written by a single person. Complex code and professional code and software are generally written by teams of programmers. So it's important for each of those programmers to understand the other programmer's code, and that can be easily done by inserting comments in the code, preceded by a pound sign so that those comments won't be interpreted by the Python interpreter, they will be ignored. So we can have comments at the beginning of our code or at the end of our code. An example of this would be this program calculates sales totals. So notice the comment at the beginning. It's ignored by the Python interpreter, but it makes it easier for the human that's going to perhaps maintain this code or make changes to it to know what's going on. Here's an expression where we're multiplying the price times items sold to calculate a sales total. We can insert an end of line comment for another programmer or a human to understand what this particular statement does. And then of course we can print the sales total. There are times when we need to use conversion functions to change data from one type of data to another. And you'll see this in your lab. So we'll take in values from the user in a string format, and we want to convert it to a float. So we'll use the float function. Anything that we put inside of these parentheses will be converted to a floating point number that can be used for mathematical calculations. So one of the things you're going to be doing in your lab is calculating the wall height. Now, we have to get the wall height from our user. So notice the use of the input prompt that we learned about in week 1. So we have input, and then we are going to prompt the user to enter the wall height in feet. This /n tells our Python interpreter that after it prints this, it should advance one line. So this prompt will prompt the user to enter the wall height in feet and then convert it to a float. And we need to do that because the values that we get from the input prompt are in a string format, and we can't do math on string formatted values. So notice this conversion here to a float. What's inside the parentheses is what gets converted to a float. Here's another example of conversion and assignment and using parentheses and printing the print function, and also comments, all the things we've learned. So notice this is a beginning of line comment that says this program is computing the total cost of leasing a car given the down payment, monthly rate, and number of months, which we're going to get from our user. So we're going to prompt our user to enter a down payment, then we're going to advance a line. The value that the user enters will be converted to an integer in this case, and then put in the down payment variable. And we're going to do the same thing for monthly payment and number of months. Notice we get those values from the user using the input prompt, and then we put it in the variable. Now notice this statement here. Total cost equals down payment that we got from the user plus the monthly payment times the number of months. Notice the use of parentheses here. This tells the Python interpreter that we're going to take this value and multiply it times this value, and then take that result and add it to down payment. The parentheses are important here because otherwise the Python interpreter would not know if we wanted to add the down payment to the monthly payment and then multiply by the number of months. Then we're going to print the string literal, notice the quotes here, total cost, and then the value of the variable that we created. This comma is essential for the print statement to be syntactically correct, and also separates out the fact that we're printing a string and then the value of an actual variable that we calculated here. Another important concept in Module 2 is importing modules. Python comes with many available modules to help you to do advanced work. One of them is the math module. It supports advanced math operations. The modules that we get from Python are located in another file, and we actually have to import them into our Python program. Now let's talk about how some of these concepts come together for Paint the Wall. So let's do our Paint the Wall lab hints now. In the Paint the Wall lab, you're going to need to get the number of cans needed to paint the wall. To do that, you need to get the wall height from the user, get the wall width from the user. Then you're required to calculate the wall area, and that's simply the width that you got from the user times the height that you got from the user. And then you're going to be required to calculate and output the total cost of paint cans depending on the color. And as you're told in the lab, different colors have different prices. So in this lab, you'll also need to use a statement like this to get the wall color from your user. So you're going to ask them to input the color that they want to use on the wall. Notice this /n means it will advance a line, prompt the user, choose a color to paint the wall, and then advance another line. Now this is an interesting statement here. Paint cost that you need to calculate equals paint colors, with this value in brackets, the wall color, times cans needed. Let's talk a bit more about that. In order to understand what this statement means, we need to talk about dictionaries. So dictionaries are Python objects that store collections of data, and the data that they store are in key value pairs. So when you have a dictionary, you can get values out of that dictionary using a key. The format for creating a dictionary is some dictionary name equals a collection of key value pairs. Let's talk a bit more about that. So, to get a value from the dictionary, we simply write this expression, the dictionary name and its key. So let's create a dictionary for the Painting the Wall lab. We're going to create a dictionary called Paint Colors, and it's going to contain the prices for the different paint values that we can use to paint the wall. This is one way to have key value pairs to get individual costs for different colors of paint. A dictionary is a good way to do that. So to create a dictionary, you put a dictionary name equals to brackets and then your key value pairs. In this case, we're storing colors of paint and their price. So we'll have the string red for the color of paint red and its price of $35. Key value pairs are separated by colons. Blue paint is $25 and a comma before we put the next value. Green paint is $23. So brackets, the value pairs separated by colons, and then a closing bracket. To retrieve the value or the cost of particular colors, we can say paint cost, which is what we're trying to calculate, equals the paint colors from this dictionary, dictionary name, and the key. Remember, the structure is dictionary name with the key to get a value. So the key in this case is this first part of the dictionary name value pair. So if the user entered red for the wall color, that would mean red would be the key and we would get a cost of $35 that would go in paint cost. Another thing you need to know for the lab is the use of the Python math module. To use that math module, we use an import statement. And again, as stated, Python comes with a number of modules and libraries, and the math module is one of them. Let's talk about a different use of the math module for your lab. Here's one simple example. Let's say we have some number 49 and we want to get the square root of it. Okay, so we can use this structure here. Says we want to use the math module and the square root function within the math module. We're going to pass an argument of num to it. This value will go in the variable square root. That's how we use the math module functions. And once again, a function is just a list of statements that can be executed using the function's name. So this function square root has all the calculations required to create the square root value for a number that's sent to that particular function. And the statements for square root are within the math module here. This is in section 2.8.1 of Zybooks if you want more detail. The Python ceiling function is one of the math functions you need to know about for your lab because you're supposed to print the answer to the number of cans you need as an integer value. So this ceiling function returns the smallest integer value for the expression or individual number that's sent to the function. So for example, if we used the ceiling function of the math module and we sent to it an argument of 23.45678, it would return the integer 24. So in Fix Me 3, you're to calculate and output the number of 1-gallon cans needed to paint the wall, rounded up to the nearest integer. So we would use something like this. Cans needed equals math.ceiling and then the gallons needed. So if we said we needed 2.47 gallons, that would round to an integer of 3 gallons. Okay, so you'll need to import the Python math module to do this. So this completes the week 2 concept video and lab hints. If you have further questions, please email me to set up a virtual lab appointment and a virtual office appointment, and of course I'll be posting the final solution to this lab during week 3. Thank you for your time and attention during this video.